Assalamualaikum. Okay, so we continue this video with the Mauvers theorem. Alright, this is used to find the powers of a complex number. Okay. By the way, if the complex number, let's say a complex number x plus yi, okay, this would be in the standard form, right? If it is in the standard form, okay, it will not be very easy to find its powers unless it's just a power of 2, right? If it's just a square, then it's not that difficult. But let's say we have to find the powers of a complex number up to the power of 4, okay, or up to the power of let's say 5, right? Okay, so if this complex number is maintained in the standard form, then it will be very tedious. Okay, in fact, it is very time consuming to find the powers in the if it is in the standard form. So the easiest way is actually to use the DeMoivre's theorem. But to use the DeMoivre's theorem, we have first to convert our complex number in the polar form. Alright, so the first step is to convert or use the polar form. Okay, convert to polar form. And then the formula is as simple as this one. You want to find the power of a complex number, okay, raised to the power of n. So the modulus r also you raise to the power of n, and then the argument, okay, you multiply by n. So if you multiply the argument of cosine by n, you also have to multiply the argument of sine by n, right? Because these two arguments must be the same. So this is the formula called the Mauvers theorem, and this is the formula to find the powers of a complex number. Alright, so we proceed with one example. This is given in the standard form. Okay, this complex number is given in the standard form. So what this question wants is find this power, okay, in the standard. Find this power first, and then your answer must be in the standard form. So it means, okay, we have to do the first step is to convert to the polar form, and then we use DeMoivre's theorem. Okay, so first step is convert to polar. Okay, convert to polar form, and then the second step is use, okay, the Mauvers theorem, and then convert back to standard form. Okay, so it's actually quite lengthy. Convert back to its standard form. So we start with finding the modulus. Therefore, and by the way, before we forget, okay, the x is a positive value and the y is a negative value, right? Y is -1. So the complex number would be in, if x is positive, y is negative, complex number would be in quadrant 4. Okay, so we determine the quadrant first. Then find the modulus. So that will be this 1 squared, -1 squared, and find the square root of. So 3 plus 1 is 4. Okay, so 4 is 2. Okay, and then find the argument. That would be arctangent -1 over square root of 3. When we calculate, okay, it doesn't matter whether you want to use radian or degree, because in the end you still have to convert to the standard form. So in this case it's up to you. So let's say you want to use degree, okay, but it's not going to be in the argument is not going to be negative 30. Alright, because the argument of a complex number must be between 0 and 360. Okay, so please make sure we use the correct angle, which is 330. Okay, so the complex number, write the complex number first. This is the complex number 330 plus sine 330i. Okay, this is the complex number, and then we have to find the power of this complex number, so raised to the power of 5. So it would be 2 power 5. Okay, using the Mauvers theorem, 5 times 330 and plus, okay, sine 5 times 330i. Okay, and therefore it's going to be 2 power 5 is 32. Okay, and 5 times 330 is 1650. So this is the complex number. Okay, 1650 plus sine 1650i. Okay, and then put the complex number in the 0-360 range. So 1650 minus, okay, minus 720, that will be 210. So the complex number is cos 210 plus sine 210. Okay, so what I'm doing is I am putting this in the range 0-360, this one. Okay, so I have 210, 210, and then finally how do we convert back to the standard form? We simply multiply. So cosine, okay, find the value of cosine 210. That would be negative 3 over 2, and sine 210 is half, right? Okay, and then simplify or simply multiply through. That will be 16 3 plus, sorry, this is I here, plus 16i. Okay, so this is the answer. So if you want, you can write it nicely here. Power 5, that will be negative 16 square root of 3 plus 16i. Okay, so that's the answer. And if we check, okay, the solutions, the answer, okay, so this is the answer. Okay, all right, this one is not given in the standard form, so we have to change back to standard form. So just calculate cos 210 and calculate sine 210i. Okay, and then you simplify. So that's the answer, plus 16i. Okay, so this is the answer, or how we find the powers of a complex number using the Mauvers theorem. So the next video would be coming up next. All right, so that's it. Assalamualaikum.